Hello, everyone. Welcome to Foresight's Biotech Group, sponsored by 100 Plus Capital. Today, I'd love to introduce Brad Younggren, who is the CEO and co-founder of Circulate Health. He served as Chief Medical Officer at Q Health, Shift Labs, and Mobisante. However, most recently, he served as the Chief Medical Officer and President at 98.6, where he led the AI team. He's an emergency medicine specialist and has worked as an Army physician. And today he'll be joining us to talk about therapeutic plasma exchange and the work they're doing at Circulate. So thank you so much, Brad, for joining.
Well, thanks, Lizzie. Appreciate it. And thanks to you all for attending. Hopefully it's a nice intimate group. So, I want to make sure we have time for questions. It sounds like some of you have already done some form of plasma exchange. So certainly want to make sure I have time to answer questions. And the goal today is just to talk a little about what our strategy is around plasma exchange. We're going to dig in a little bit into the research. I don't know how many of you caught our publication came out in Aging Cell, finally, a couple of weeks ago, which is a great milestone for the company and really the cornerstone of our sort of patented approach to plasma exchange. And then a little bit about some of the details around that trial, and then make sure we have some time for questions and see what kind of thoughts you may all have. So with that, I appreciate the introduction. Yeah, I'm Brad Younggren. I'm the CEO of Circulate Health, physician by background, but I've been spending the last 20 years in medical technology. Built the first FDA-approved mobile phone device in the country, was at Q Health, helping them build their at-home COVID/flu diagnostic test platform, and then spent 7 years at AI Primary Care, which is translational to this in the sense that is very interested in how we can use technology to improve generalized primary care, which is a lot of what longevity industry is all about. So I'm excited to be directly in that space the last couple of years with Circulate. I'm going to share my screen and we'll kind of hop in, assuming everyone can see that. Lydia, right? Where you can see that? I just want to make sure before I roll here.
Looks great.
Great. Okay. So again, we're going to talk a little about the research of Circulate Health. The background of the company is that it was really incubated by Coastal Ventures, where we spent primarily, the original name of the company was Lifespan, which is a crowded namespace. So we changed the name, but it was really just a research company in the early days focused on doing the first human trial with therapeutic plasma exchange. And then essentially translating that research and knowledge into a business which could help enable other clinics around the country to offer this service. And that's essentially what we do. To categorize this in a nutshell, is we're going into currently 22 clinics in the United States and moving abroad as we speak to really offer our sort of approach to these clinics and bring our expertise, knowledge, our nursing know-how, our physician expertise, and our ability to manage the protocols safely and correctly to those cohorts of patients that exist in other clinics. So we don't actually have our own clinics in the world. We just operate in partnership with what we call our affiliate clinics. And that's allowed us to really kind of move plasma exchange pretty fast into the ecosystem here, and to allow us as a follow-on to start to collect data, which we all love, to understand a variety of additional questions that we'd like to answer as it relates to plasma exchange. So I'm going to minimize this here. There we go. So today we're going to focus on our philosophy around how we believe, and we think our data shows, that therapeutic plasma exchange can reduce inflammation and age-related diseases. This is something that you all are very familiar with, but just as an introduction, and we just saw that announcement from from Germany around approaching aging as a disease just this week. So I think this is becoming a hot topic. But if we think about it from just the economic impact, we know that aging is the biggest single risk factor for disease, and we're spending a ton of money in the US market related to healthcare costs for chronic disease. And obviously not just related to therapeutic plasma exchange, but more broadly, as you all know, if we focus a lot more on preventive care and mitigating disorders of chronic disease before they started, we could have a significant impact and likely significantly lower the cost of healthcare burden in the United States. Additionally, we're going to talk a little bit about this at the end. I'm going to touch on the growing information and concern around environmental toxins, including micro and nanoplastics as a modern health risk, there's not that often that new sort of diseases come up as a physician that you never ever studied in your earlier days. The first of those for me, and I'll age myself a bit here, was the microbiome. Never learned about it as a medical student. All of a sudden, this word popped up, and there's this whole new industry of things to learn about, which is always great as a physician. And then I think this notion around micro and nanoplastics burden has been talked about, but I think just in the last couple of years, we've seen legitimate data coming out about the potential impact and the burden we're seeing in the human body as it relates to micro and nanoplastics. When we talk about what the value of a healthy life, and I know with this audience, this is something you all likely, if you're here in this call, you agree with and you believe in. We know that we have this sort of global aging process going on. Many of the population triangles, as you call them, are being somewhat inverted. We're sort of at a flat line, soon to be inverted. Japan and other countries have already inverted, or more of the population is aging above 65 compared to the young population. And obviously with this just generalized shift in population, let alone increasing global disease burden, all this relates to a massive amount of healthcare spend to take care of this population. So what we do know is that we can get trillions of dollars of value by extending healthy life for these individuals. So, and this is really a focus of language we use and I use at Circulate, which is, yes, a lot of what we're doing points to the potential for longevity or improving an extension of life. But the reality is we don't know that for sure. Those are all triangulated assumptions. But what we do know is healthy living and the quality of life of patients in their younger and mid years, and even as they age, if we can convert more of those years to healthy living, they can have a massive improvement in quality of life, but also in total cost of care. So from the perspective of what Circulate is focused on, and we obviously are living in a very, very narrow lane of this very large freeway, and we're focused at this point in time specifically on bringing plasma exchange to the general public's knowledge and awareness. And so what is plasma exchange? Well, we'll talk a little bit more about this, but there's a machine that we use that centrifuges the blood and separates it into its main components based on density. This allows us to essentially remove, in our case, plasma, although obviously when you give platelets or donate blood at a local blood bank, you're obviously donating different components of that, of the whole blood. And the idea behind plasma exchange, and this is a whole hour-long talk in itself that I would never do, that I would leave to our physician apheresis experts at Circulate, but hopefully they won't get too mad at my description of this, is, this idea that you have an intravascular compartment. And we target essentially removing plasma from this intravascular compartment. There's obviously an extravascular compartment. We'll talk a bit about that as it relates to our research, but there's a large component of inflammatory cells, cytokines, senescent cells that live in the extravascular compartment. But there's a flow between these two compartments. And what has been shown essentially is you can target the intravascular compartment because there's this lymphatic diffusion and return to that compartment. You can actually have an impact on that extravascular compartment, even though you're only targeting from a therapeutic perspective, the blood and the components that are living in that intravascular space. So on the right here, you can see the machine. I always like having a photo of that because it kind of orients you, what the heck does this look like in actual practice in our clinics? So we have a nurse that's sitting at the bedside with our patients, or typically in a chair, in a therapeutic chair. And there's a machine that essentially is a large centrifuge for all intents and purposes with a massive computer system. And you can see that there is essentially blood being taken out of the patient here, where it undergoes this plasma separation. When that plasma is separated from the other components of the blood, is then essentially discarded. And in the upper right-hand component of the picture here, you can see that yellow substance. That's typically what plasma looks like when it's separated from the blood. And that's literally what we're discarding from your body when you get therapeutic plasma exchange and Circulate. Then the next component is, obviously, as you're removing plasma, that has volume. So you need to return some sort of volume component to the human, or else you'd obviously have massive problems with blood pressure, things of that nature. If you go and donate blood at a blood center, it's a much smaller volume as a comparator. We get asked this question a lot, but a lot of times it's a much smaller volume of blood or plasma that you're donating in that scenario. If you're lucky enough to have a blood type that allows you to do so. In Seattle, I don't have the correct blood type. I couldn't even donate plasma in the city up here where I live. But we use a substance called albumin, and that has a couple functions. It actually returns plasma volume, so we don't have any blood pressure problems when we're treating patients. So we can do this very safely. But it also has its own anti-inflammatory, antioxidant properties. That's another reason why we used it in the study, was we believe it has an additional component beyond just saline, which is typically what you'd receive if you went to a blood center. So when you think about therapeutic plasma exchange, it's not in itself a new technology. Our patented protocol, the amount we take out, the substances we replace you with, those are more novel. But the machine itself, and its core components has been around for quite some time. The device is FDA cleared in the US and in many countries because, again, it's doing a lot of these core functions. There are some very sick patients that on rarity get treated in the hospital with therapeutic plasma exchange. And, a lot of our experts come from that world. And then there's obviously blood centers across the US and the world where you can donate plasma. And that's the other place you'll typically see this machine technology. We're really the first large-scale outpatient therapeutic approach to bringing therapeutic plasma exchange outside of the hospital. So that's kind of why we're different. I view it as being a coming renaissance of plasma exchange, if you will, or plasmapheresis more broadly, as we look and explore, if we bring this out of the hospital paradigm, what are the innovative and potential reasons why we do this in patients? And we can get into some of those kinds of patients that we're treating sort of nationally if you have questions about that. So we remove your plasma, and as such, we're removing toxins, cytokines, et cetera, and we're exchanging that for albumin and a little bit of saline. We're actually returning your red blood cells, we're returning your white blood cells and your platelets. So it's kind of amazing to me as a clinician how little of an impact this has on those components. Like the machine is quite good at separating these components out and giving you back all your components. So in other words, your red blood cell count doesn't significantly drop when you get this treatment. And that's important. We want this to not only be therapeutically beneficial for the patient, but it has to be safe. And that was one component of my evaluation of this as we brought this out into the outpatient setting was, do we believe we can do this safely with the highest of quality at scale? And obviously we believe that to be the case. So we've taken this patented protocol that we've developed with our research and are working and partnering with our affiliate clinic network to provide therapeutic plasma exchange broadly across these 22 institutions across the country, currently and continuing to expand. When we talk about where we fit into the quote longevity space, which is a broad term, we view ourselves as being scientifically grounded and professionally administered. And that sort of puts us in this upper right-hand column relatively uniquely. There's a lot of other things going on in the industry. And what we really wanted to do at Circulate was continue to grow a reputation as being a scientifically based organization. And again, for us, that doesn't mean primary research has been done only in rats or C. elegans worms, but actually research that is grounded in human-based science. Because we all know, and all experts agree that I've heard in the space that, rat and C. elegans research doesn't necessarily directly translate to human outcomes. We need to follow on those early research endeavors with human trials. And so we've done that. We've done the investment in that. We're really proud about that. And that's the basis and cornerstone, the fundamentals of what we believe our company is about. It's not to say that many of the things mentioned on this slide are not beneficial to humans in the context of health span or lifespan. It's just calling out the notion that, even when it relates to metformin and rapamycin, which are and even NAD that are commonly taken by patients in this industry, we need better science to prove not only the efficacy of the drug, but sometimes the methodology of how we take in that drug. In other words, does oral or IV formulation matter in that context as an example? So we need more work on EBU. We need more work on exosomes. I get asked about this all the time because many of our clinics are not just operating therapeutic plasma exchange with us. They're doing many other things in their longevity centers or chronic disease centers. And that's where we live most of the time, is either in these sort of longevity centers or individual physicians that have longevity or chronic disease focus centers where we can provide this therapy safely for them. And of course, I think we'd all agree in this call. And when my friends call me and ask about, hey, should I start metformin? Hey, should I get therapeutic plasma exchange? I'm like, I always ask the question, have you optimized your diet, sleep, and exercise? Because we know without a doubt that those are the cornerstones and the largest impact you can do to improve your health span and likely longevity. All this work really stemmed from decades of research, what was referred to as endocrine parabiosis studies in rats. Happy to dig into this in the question period here if that's helpful. But just to say that, in a simple description, basically sewing an old and young rat together that are genetically similar, essentially combining their circulatory systems. We know that for the repeated multiple studies that this is not really refuted anymore. It's generally accepted in the scientific community that this was a reproducible study where this showed a generalized reduction in biological age of the old rat, an increase in age of the young rat, and associated hallmarks of aging that you would expect to see with that effect. So this is obviously spurred out a whole industry of companies that are looking for the next GLP-1 as it relates to longevity, right? If you could find out that molecule, then of course you'd have a winner in the context of the biotech industry. So lots of people are looking for that. The philosophy of the research that was done at Circulate and what we call the Circulate trial was, well, it's a very complex cascade of events that's occurring as it relates to healthspan and the inflammation. So taking a different approach, a more holistic approach, could we see a positive impact on inflammaging if we just approach this by using therapeutic plasma exchange to create a dilutional effect by removing a lot of the sort of quote evil humors in the bloodstream that we accumulate in time, living the lives that we lead, etc. And that was what the Circulate trial was proposed and was executed on. We already knew there were other studies already out there. Toby Kiprov really was an early adopter and advocate for looking at this. So I always want to give him credit where credit is due as being just an early physician leader in this space. He was really led the AMBAR study, which some of you may be familiar with, but specifically focused on Alzheimer's and dementia and the use of therapeutic plasma exchange, which has some very promising signals, but certainly needs more work. And continued research on IL-11 and other immune system rejuvenation. And we're continuing work looking at environmental toxin removal because we know this is a really important topic in the current state of affairs. So what did the Circulate trial show? So, there's a lot of things this trial showed. There's a lot of things I wish we could have done if we had endless money to continue the study into perpetuity, but we were able to really glean a lot of important information. I'll go into a little bit more detail than is represented on the slide as it relates to the trial. So the trial had 3 arms. 3 of those were different treatment arms that I'll go into detail on. And there was 1 sham arm, meaning in the sham arm, patients had blood. The machine was behind a curtain. So the patients didn't know what was going on behind the curtain. This took a little bit of logistics to do this safely with nursing and so forth. But what this allowed us is to have single-blinded study where the patients didn't know if they were getting true therapeutic plasma exchange or if they were in the sham arm. And those patients actually just had blood circulated out of their body and just went through the machine, but nothing happened, and then just recirculated right back into the patient. And then the arms were mostly just in terms of determination of different frequencies of therapeutic plasma exchange and the presence or absence of IVIG administered, IV immunoglobulin, and administered after the therapy. The first cohort of data to be collected was around things like grip strength, get up and go, which is sit from standing and walk 6 feet, balance, some mild cognitive tests like standard cognitive tests as well. That was not represented in the paper we just published, but will be represented in follow-on papers, which all looked very promising as well. So we had a lot of positive signal in that area. Interestingly, even with just 3 months of therapy, which we think needs to be published, some of that being statistically significant. So we're excited about that. The second cohort of data, which we're just kind of digging into now, some of it's represented here in this talk, is we ran the blood. Obviously, we were in partnership with the Buck Institute. Eric Verdin is our co-founder at Circulate. And we ran all the blood samples through the Buck to do proteomic, metabolomic, lipomic analysis. So we ran all the samples, which were essentially pre and post-treatment through the entire trial on these patients, so many, many blood samples, through those metrics, and have developed a massive data set as it relates to that. And we're just starting to look at some of those markers from a high level, and we'll get into a little bit of this in subsequent slides. We were just looking at initially to see, we have sort of an expected phenotype of change we would like to see as it relates to proteomics and metabolomics, et cetera. And are we seeing that as it relates to the trial? And we did. The third one, which has gotten a lot of press, influencers and others have picked up our trial and talked about it. And I think it's easier for people to wrap their head around really rapidly, is around this 2.6 years of biological age reduction. So many, if not all of you, are familiar with biological clocks. There's lots of controversy and discussion around these, how you could use these effectively. I tend to take the approach that these clocks are very effective at when you're applying an intervention, that you can look at the clock pre and post and see what impact the intervention is having. Of course, there are many other variables, I acknowledge that, but this is one of the best ways we can do to look at therapeutics right now. But I think the next generation of clocks are looking exceedingly promising in that regard as we get into systems age clocks. On the right, you can see the three first columns were the therapeutic arms, and the fourth column was the sham arm. Blue coloration means reduction in biological age, so that's what we were targeting and hoping for. And the last column is the sham. So I'll start with the sham because it's easy to see. It's a bunch of red, preponderance of red or neutral. So what's interesting in 3 months of therapy, just through generalized aging and potentially through some impact of the machine itself, because the machine is a centrifuge, so it's actually spinning blood, but we're actually seeing an increase in biological age in patients who were put in the sham arm. So that was just an interesting finding in itself. I think it provided a really quality comparator to the three columns on the left, which were the three therapeutic arms. What you see here is obviously the first column on the left has the longest and strongest impact, especially around the system age clocks, which I think are probably some of the best clocks out there. And those showed profound impact for patients receiving twice a week therapy for 3 months with IVIG therapy. The second one that looked very promising was just one treatment a month for 6 months. So less per month, but more treatments overall. So that's interesting. And even the third one without the IVIG, but doing 2 treatments a week for three months also had mostly positive impact. So this is very exciting for us. We were really excited about the data. We didn't know obviously what the results would look like when we embarked on this study, but had theories around this. And so this really demonstrated in our mind exactly what we're hoping it would show, which is that this methodology, this therapeutic plasma exchange, can have an impact on inflammaging and hallmarks of aging as represented through all these different areas of data collection that I just mentioned. Real quickly to dig in a little bit deeper, because I know this group is going to understand what we're talking about here, is we wanted to look and see are there proteins that are increased with treatment that we would hope would be treated, right? So to highlight here, we found 564 proteins with statistical significance. Ones mentioned here are ones that are more commonly associated with reduction in aging, or markers that would be related to improved aging. And so we were excited to see a lot of positive impact on some of these proteins that we had hoped to see. And this is obviously, like I said, the work we did in partnership with the Buck. Similarly, we wanted to see, well, when we do therapeutic plasma exchange, are we seeing reduction in proteins that we would hope we would see a reduction in as it relates to therapeutic plasma exchange? And we fortunately did see that as well. As you can see here, highlighting a few of these apolipoprotein changes were fairly significant. And those are things we would really want to see as it relates to the therapy itself. It's not completely surprising that you're removing apolipoproteins, obviously, when you do plasma exchange, but obviously seeing impacts on serum amyloid as well is very encouraging. So in summation, the therapeutic plasma exchange, the Circulate trial, showed this reduction in biological age. We're seeing immune system improvements holistically and broadly across these cohorts of patients, improvement in biomarkers, and we think an improvement in wide-ranging benefits. Also not certainly published in the initial paper that was in Aging Cell 2 weeks ago, but we saw that there are certain markers, sugars, liver enzymes, creatinine, that actually had a correlative impact on the greatest reduction in biological age. So it's also very encouraging because we could hopefully translate simple lab tests that we typically do in patients that aren't super fancy and spancy, that are available very broadly, and use those as not only ways to measure the impact of the therapy, but also potentially in time, select patients we think will be, good responders to the therapy. More to come on that as we build out our data set. One of the things we're excited to do in partnership with our affiliate clinic network is to continue to collect data so we can answer additional questions in the future as we can follow these patients out in time. Another area of work that we're doing, we haven't released this paper or this research yet, but I'm happy to talk about it broadly with you all because I think you'll find it pretty interesting, is we're doing a bunch of work independently and with the Buck and with our affiliate clinics, looking at the impact of micronanoplastics or the impact of therapeutic plasma exchange on micronanoplastics and other toxins as well. Obviously, as I referenced earlier, this growing threat of microplastics is this profoundly new conversation. Many of us were avoiding plastics when we could in the past. There's such a ubiquity of these substances in our daily lives, but some of the potential health risks has only been highlighted in the past 2 years as we've come out with papers in the New England Journal and others showing microplastics embedded in a variety of organs to include carotid arteries, to name the least. So we know that these are not inert substances in the body. I don't think that's being disputed anymore as well. They can cause cellular damage, oxidative stress. They can have a significant disruption of our endocrine systems. So we need to do a ton of work here to understand what's the impact, and then at what level do we need to mitigate the risk. Obviously, as you all know, avoidance when possible is the best risk mitigation tool out there for this particular problem. But we've been out looking at, is there a way to provide a therapy as well as it relates to micronanoplastics? And we're very excited to be doing the work and leading this. I confidently can say we have the largest data set of any therapy in the world right now as it relates to potential reduction in the micronanoplastics. And we're very excited to continue that research and hopefully be back on here sometime in the future to present that data to you all, because I think it's very exciting. So as you can imagine, plasma exchange, and we're doing a bunch of research here to understand this deeply, but it's not good enough to say, well, we think plasma exchange itself will remove plastics. That may or may not be true. We believe it's worth investigating, and that's what we're doing right now. But we need to understand a bit more where the plasmas exist in the bloodstream as an example, so we can better target the removal of those microplastics. There may be different ability to reduce microplastics versus nanoplastics based on particle size. In some instances, membrane filtration may be superior to plasma exchange. These are the questions that Circulate's out in answering right now. So you will not see us sort of advertising micronanoplastics reduction as a reason why you should look at therapeutic plasma exchange. Again, going back to the earlier slide, we want to be trusted and grounded in science. When you see stuff we release, you want to know it's on human-based trials, and then we're putting in the time and energy and expense to make sure that we're giving you legitimate information that you can trust. So we've already done the first human trial, the Circulate trial. We're continuing to do more research in healthspan and lifespan as it relates to therapeutic plasma exchange. We're growing a network of partners, and it's going to allow us to accelerate data collection at a much faster speed. To put it in comparison, when we did the trial, we only had one center for those 40 patients. So now we have 22 centers to draw from for patients that would like to participate in this broadly. And I'm excited about this network phenomenon and what we can do with it and the power. We can answer questions very rapidly, targeted questions about specific toxins, about specific benefits to health span and lifespan. And this will be the cornerstone of how we get this data out broadly to the world. And we're essentially coming into clinics and offering this service. So it makes it easy for the clinics themselves who are focused on 1,000 things, but would like to bring this in their clinics. It allows us to come in and essentially do that. It's our nurses, our machines, our protocols. And so they're just working in partnership with us to provide patients, and we educate their physicians in the clinics on talking about this and prescribing this therapy. And they're great. It's a great model, works really well for us, allows us to grow on the commercial side as well as grow on the research side. So we think that there's a lot of roles for therapeutic plasma exchange as it relates to health span in the future. We think it can remove a variety of chemicals. We're going to go out and prove that. We think it can promote different aspects of longevity, or I more commonly referred to as health span benefits. What we learned from the study as an example, if the addition of a small dose of IVIG had a significant impact in improving biological age. That's very interesting. For those clinicians in the call, our dose is very small, very what I would call subtherapeutic for what you typically would use in a hospital for IVIG. So the questions remain as to why, but I think it does point to the notion that when you remove toxins from the bloodstream, you may be prepping the body to accept other forms of therapies, which could have a potential exponential impact for the patient. So we would like to explore that as well, look for concomitant therapies that could potentially go along with plasma exchange. And there are patients and research ongoing that you are probably familiar with as it relates to a variety of illnesses. I mentioned ANMAR and Alzheimer's, but it goes far beyond that. Patients are, and there's research trials in Europe looking at long COVID, long infertility, et cetera. So just appreciate the opportunity to come here and present kind of where we're at. We've come a really far way in the last 5 years both on the research side and really getting this into the hands of patients, which we're very passionate about. We have a nice growing team of clinicians that are we're pulling out of hospitals to provide this from a quality and safety perspective. And so I'm just incredibly proud of the team and what we've been able to do, especially over the last 2 years. And we think this is really going to redefine therapeutic plasma exchange and really bring us into a renaissance of this particular therapy. It's about time to get it out of the hospital and all the problems that relates to having hospital-based therapies. It's going to be much cheaper to bring this out of the hospital, frankly, and allow this increased access to this for patients for a broad-based set of indications. And again, just to remind you, this is kind of how we work with our clinics. We're providing essentially everything, the protocols, nurses, and supplies, and the clinics are really providing the patients, the physician oversight at the individual clinics and the treatment rooms. So I will pause there or end there for the presentation portion and see if anyone has any questions, Lydia.
Thank you so much. That's awesome. We have a lot of excitement and a lot of questions in the chat. So I guess we could just move through the chat questions first. And then if we have time, then we'll move forward with other people's questions. So
Great.
The first question that we have is from Steve. Steve, I can read it for you or you can present it yourself.
Oh, there it goes. I might assume it's a little bit slow to respond. Okay, I was asking about, is there any consideration about concurrent use of plasma exchange and either bloodletting or blood donations for purposes of lowering iron stores?
I'm sorry, I just inhaled some coffee there. So as a comparison, we're taking out significantly more amount of plasma when we're doing that. We do monitor the benefit. We are doing a lot of pre and post testing on patients. Broadly, we have we don't just offer plasma exchange up front without getting pre-testing done. There are certain patients that won't qualify for it. Obviously, bloodletting is a methodology for reducing iron stores. Hemochromatosis, as you're kind of pointing to there. We're focused right now on just removing plasma from the body, although the machine itself can be used for a variety of those clinical indications.
So if you donate a pint of blood, there's the loss of plasma associated with that. Is that significant in terms of your testing and how much plasma exchange you can do for safety reasons?
Yeah, really all the protocols when you donate for a pint of blood, as an example, you're really, whether you go for platelet donation or even plasma donation, those volumes are profoundly different in regards to how much plasma you're taking out. My friends ask me, I'm like, it's not that it's zero. So you are getting some benefits similar to what we do, but not anywhere near it. And it's never been studied, right? It's never been studied. But the reality is that when I get my plasma exchange taken off, it's over 3 liters of plasma. I'm 6'4", just to put it as a comparison, which is profoundly different than you'd ever get if you went to a blood center. Plus, they're just returning, because it's a small portion, they can just give you normal saline back, and that's fine from the context of intravascular support. We're using albumin, which has its own benefit, and we're doing a much, much larger volume exchange.
Yes, but you're returning red blood cells that I'm particularly trying to eliminate.
Correct.
Yeah, so that's why I wanted to know is there is a recommendation to avoid, either process in the vicinity of the other.
No, what I would say is, if you ever want to talk to our, apheresis physician experts, they've been doing this for 30 years, much longer than I have from that perspective. But I think the reality is, I look at it as you're basically getting back all of your RBCs that you, for the most part in total, that you started the day with. So if you're targeting that as a therapeutic goal, then with our current protocol, that is not being achieved. Now, of course, all of our nurses, all our physicians, they come from the world of apheresis, the ones that are operating this machinery for us, building our protocols. We certainly could create specialized protocols potentially, right? That's not outside the scope of what we could consider doing in the future. But right now, we're offering our sort of singular patented protocol from a simplicity stake, and just to make sure we can get that out there for patients that are targeting specifically plasma exchange for healthspan and lifespan. But there are other things we could do when we have the machine in the room with the nurse, right? I mean, it would be safe to pursue those. Maybe not on the same visit, though.
What about only doing 2 liters instead of 3 liters, and so that you can afford a little bit more plasma loss or a blood donation?
Yeah, I think it's an interesting question. I think I'm happy to follow up with you on that. I'll circle back with our Bob Weinstein's our sort of plasma guru, apheresis physician guru, and I would defer the question to him. But we will explore it, and I will try and get back to you if that's okay to make sure we get you the proper answer.
Appreciate it. Thank you.
Yeah, of course.
Awesome. I think the next question is from someone in this meeting named Zoom. I'm happy to read your question, or feel free to speak up.
The mysterious Zoom.
Okay, so I guess I'll go for it. From the chat, Zoom asks, from the chart, it looks like the sham control group had a pro-aging effect. Is this the same physical process in the case treatment arm as well, accepting the plasma separation, i.e. the same plasma is put back? Does this imply there is room for optimization of the protocol in the future by changing the handling of the non-plasma components?
I think I got that. So there's a couple different theories around why we saw increase in biological age in the sham arm. I don't think we could confidently say for sure. I think it's probably a combination of continued aging, not getting therapy, and then also potentially some component baseline of the machine itself, right? And the impact of the machine and the centrifugation that's going on in the machine. Whether it be additional benefit, I mean, to remind you, we're not infusing young plasma and exchanging. We're literally just taking out a ton of your plasma as much as it's safe to do and literally throwing it in a trash can in a bio waste bag and not returning it to you. So from our perspective, and the theory that was behind the Circulate trial was, we think that the pure removal dilution, if you will, by removing a large volume of plasma will have a positive impact. And that's kind of what we saw. And obviously none of that was happening in the sham group. They were getting back all of their plasma that they started with no exchange at all happening. So all of that was unchanged for them from like when the treatment theoretically started.
I'm not Zoom, but I think their question was, if let's say just running your blood through the machine gives you -3 years, and then removing the bad stuff gives you +7, your net +4. Can we somehow counteract that -3 from just using the machine at all, so we get +7 net instead of +4 net?
That's a great question. The short answer is no. And that I don't think there's any way, because if you think about it, if you really want to target removing plasma from the body, you're going to have to centrifuge the blood, and the machines are essentially relatively the same. It does point to something I've noticed coming in this industry, that there's definitely room for technological innovation here as it relates to it. So I think it's a great question. There could be other machines in the future. Some of you may be aware of, sometimes there's membrane filtration columns that can be used instead of plasma exchange typically. So in those scenarios, you would be returning the plasma, but running it through a filtration mechanism, and essentially still though uses the same machine typically that you use for plasma exchange. So you're not avoiding that part of the procedure, if you will. So I don't think we have a good alternative solution to avoid using the quote plasmapheresis machine at this time.
I have a quick point of clarification. I think I might be confused about something. So in the sham arm, the subjects had something removed and then put back, and it was the same thing that had been removed. Is that correct?
You can imagine, yeah, the blood was being
Okay.
out of their arm, run
Right.
through the machine, and just recirculate
Great.
immediately back in. Exactly.
And in the case of the treatment arms, the people had something removed and nothing that was removed from them was put back. Instead, the osmotically matched albumin was given back to them. Is that correct?
Mostly correct. Yeah. I mean, there is some return of plasma, like a small amount of plasma, but you're correct from a.
Okay. So improving the handling of the stuff that's centrifuged actually wouldn't make a difference, because in the treatment, you're not putting back the thing that is handled. You're putting back mostly something that's made, for replacement. So, I mean, yes, maybe like centrifugation beats up your red blood cells really bad, but who cares? Because like you said, you're throwing that in the trash. you're giving back the red blood cells. I guess, yeah, that's what I'm not understanding. You're giving back the red blood cells and not the plasma.
Correct.
Okay, right.
Yeah.
So if there is some damage that's done to the pellet fraction stuff that you're putting back into the body, it is possible that that's contributing negatively to like biological age metrics.
Yeah.
Per the question. Okay.
Exactly. Like we don't know. I will say I've asked 3 apheresis experts, about this, and all 3 of them said we don't think that there's really a significant impact to the machine on the biological age shift we saw on the sham arm. So that's interesting. And so I think that the safest thing to say, we just don't understand why that happened.
Thanks.
Yeah, it's interesting. So whether it's those patients are just living again for 6 months, and that's causing an increase in biological age as measured by these tests. And the one thing I didn't mention when we talked about the trial, but it's worth just highlighting, is we ran every sample through all 36 biological clocks that were on the market at the time that we ran the study. So we didn't just run through 1 or 2, right? We ran through every one. And some of them are done very differently. Some are focused on systems-based, some are organ-specific clocks. We saw positive changes through all those different kinds of clocks, which is very interesting. Some are methylation, some are not. Is that an example, right? So, but yes, to your point, we just don't know.
Okay. I think, Kiara, you had a question? I can also read it. Well, maybe we can just move to Chris's question. How much does it cost?
Yeah, I mean, it's a great question. Our relationship with the clinics is they typically are ultimately controlling price, because obviously if you have a clinic in New York City, the cost of the maintenance of that clinic just in of itself is very different than different parts of the city, right? Our approach is we don't control their consumer pricing. Most pricing but obviously as a corollary to that, I know all their prices because we're partnering with all of them. So I think the general price on average around the country is usually about $8,000 to $10,000 per treatment. Some clinics allow a discounted price for multiple treatments. Some are putting the therapeutic treatment into like a tiered subscription-based pricing model. So that's why it gets complicated. Like where it's just one of the many things you get if you're a member of the clinic.
Is a treatment a session that happens in a day, or is it a course of sessions?
1 session.
Wow. So like the devil's advocate would say, like, this isn't like a very democratically accessible technology. Like, is there any anticipation that like over time the cost basis will go down? Or is this like for people who can afford to go to the spa for $10,000?
No, I mean, the short answer is everyone at Circulate would love to bring down the cost and increase accessibility. I mean, historically, like in the work I've done in previous jobs, that was our whole goal, was like democratizing primary care. So like similarly to that, from a philosophical perspective, if there's anyone that's gonna be able to bring down the cost, it's us, because, we have a COO, Robbie Sweetcher, with immense experience. He ran Amazon Prime for years. Like, we're interested in lowering the cost, and we're able to do that through supply chain management and, using our nurses in the most effective way where we can lower the cost. And so we believe we can, continue to drive costs down in time as we bring this out. But obviously we're early stages. We only have 22 centers across the United States, and we're mostly doing almost all the treatments across the United States right now for this therapy. So with time and distribution, we believe we can lower the cost and make this more accessible to people.
And just so I can kind of calibrate this, thank you for that answer. I appreciate the frankness.
Yeah.
In the treatment arms of the study you showed with the heat map, how many sessions had those people experienced?
You're seeing the different blocks are when the patients were getting 6 sessions.
Okay.
Over 3 months or over 6 months, depending on.
Right.
So it's
great. Thank you.
Yeah. But what we highlight in some of the color data we presented is a delta just essentially after 2 treatments. So we know, and we know that there was benefit, like not just with 6 treatments, we were seeing benefits, and we see that clinically as well with, not as many treatments.
Thank you.
And just to do a follow-on question to that, what do I think about that? I think everyone's going to be different, and that's what we're trying to figure out. Like if you have a lot of insults to your body, you smoke, you don't sleep, like of course, like your inflammaging levels are going to be different than somebody who's optimized around those particular variables. And I think that all of that will likely have an impact, as well as your genetics, on how many treatments should you get and when should you come back and get another treatment, right? We want to ultimately use biomarkers to measure when the appropriate time to come back for your next treatment is.
Is there any path to reimbursability?
The short answer, yes. Having done this in previous roles, it's a long process in the United States. We need to collect data first. This is just Brad Younggren's opinion from basics.
That's great. That's what I want.
Perfect. We did this a little bit in previous work I did in my AI job, and like, you need to collect the data first. The insurance companies are not going to jump up and down and be like, hey, let's go. They're not going to lead the charge on this. You need to like get the data first. Then you can get codes for specific treatments, right? Based on the data you have. And once you have codes, ultimately, when you've been able to codify it as a therapeutic option, therapeutic plasma exchange, I'll make one up. This does not exist, but like therapeutic plasma exchange for Alzheimer's prevention, like you would need to get a code for that, right? Once you have a code, then you can go to the payers and say, hey, like, this is not only a code, we have data to suggest that by being aggressive here and treating this, we can have a positive impact on the long-term outcome related to this specific process. So the short answer is yes. The long answer is it's going to take a bunch of time and data to get to that place. And again, we're the first outpatient option here ever. So like we're going to use this network to collect data so we can ultimately kind of get a better understanding of where therapeutic plasma exchange does have a role. And then that next step is what you're pointing to, which is get reimbursement for. I know that health plans with long-term love to reimburse for preventive care, right? This would fit. I'll leave that there.
Thank you.
I'll leave it there.
Greg, would you like to ask your question?
Hi, can you hear me?
Yes.
Hi. Yeah, so this is a very interesting study, but one of the things that you have not really dwelled on is the fact that you got these aging reversal effects only early on, and sustained use of the same methodology made them all go away. So you have thoughts about how you can sustain the anti-aging effect. And then the second question is, since you're bodily going in and taking things out of the plasma, which may relate to various aging clocks, and you're roughing up cells in a natural way, which doesn't really relate to normal aging, and you're putting them back in and then measuring how they look, is there a possibility that the aging reversal effects you're seeing are somewhat artifactual and not really reflective of what's going on deeper in the biology of the patient?
Well, I'll start with that last part and hold me accountable, Greg, for making sure I answer all your components to your question. But that was the intention behind doing the grip strength objective measures. That was the intention, spending the money to do the proteomics, lipomics, metabolomics, because like there's research on that. And I'm really glad we didn't just go after biological clocks. That being said, biological clocks are one way you can look at the impact of a therapy. And I think we've done everything we can to reduce the noise there by doing it on every biological clock that was possible at the time. We actually went back and used eye-age. We'd already completed the study, thawed out the blood and did it on eye-age because it was a newer one. And we wanted to get more data because there was more data that we could get, right? And so we did, glycan age, eye-age, and those are all done. Some are glycosylation, some are methylation, right? All we could do is say we did it broadly across a variety of methodologies, which means that if it was all confounding, that would mean that like basically every methodology is flawed, which so.
Well, I mean, a lot of the clocks did not show positive results, and many of them showed negative results. And your control group, I think your eye-age results were better in your control group, in your sham group, than they were in the treated, at least over time.
Can we put the slide up again?
Sure. Yeah, I don't fully agree with that statement, Greg, but we can.
Okay. The heat map slide is what I'm thinking of. Sorry for the backlighting here.
Go back, sorry, I don't know how to do it out of the mess. There you go. So you can see here, like, I don't know what you're pointing to when as an example.
All right. Yeah, you're right. I'm not seeing it right now myself, except that your immune, I guess the immune age is better in your sham controls than it is in your treatment. You have a
I
lot
think
of,
I think almost, I mean, and when you look at and read the paper, which I encourage you to do, David Furman's team did a bunch of AI analysis on this. I'm only touching on parts of the paper that leads to that 2.6 years number. But you can see here, like in the far left column, at least as it relates to the second time point. We said, and so there is issue with,
the second time point is all blank, basically. So the early time point, you have a lot of great results and very few negative results. But then if you continue the same therapy for another month, it all goes away. So that's really the question that I had.
I don't think it goes away in the third treatment there, but and we're happy to.
Well, it goes away from a statistical point of view. None of that is statistically demonstrable
There,
after a while.
well, as a comparator, like the third column shows
That's
mostly.
not significant.
What, excuse me?
That's also not significant for the most part, right?
I don't know why there are a number of statistically significant at -5 years that are even the third column. So not holistic. I acknowledge that it's not holistic across those. But
I thought I remembered in the paper that you marked statistically significant boxes with an asterisk or something, but I don't see that there. So
yeah, no, that we didn't translate over for that. I just didn't chance that. You're right. They're not all statistically significant. It's a trial of 40 patients, right? So, but we have a follow-up paper coming out that's going to go a little bit deeper into that. So hopefully that'll shine some additional light on some specific clocks and why they were statistically significant. So we'll see what you think of that one. But I'm not going to sit here and argue that this paper was end all be all. Certainly, I'm really, the amount of money we spent just to complete this study without any sense of ROI, I'm impressed with the people, or Coastal for being willing to pay to support us and making that investment, frankly, because we had no idea. And I wish more companies would do that. And yeah, it'd be great. Honestly, there are many things I could say. I wish we'd follow the patients out for a year, right? That would have been great data to have. Of course, that would have doubled the cost of the study or tripled the cost of the study. It's just and so we're hoping. Now we have this network, and then with the network, we can continue to collect data. And we're not going to stop here. We're going to continue to try and be grounded in the science. And I think what you're asking are fair questions.
Yeah, I just want to say,
Awesome.
I totally understand the practicalities and the costs of these things, and I salute you for doing the study, but definitely more work is needed.
Sure.
Well, maybe we have time for one more question. Micah, would you like to go?
Yeah, just a quick one. Did you do any psychological assessments, just like asking people whether they felt better or worse compared to before, particularly in the blinded study?
Yeah, we did. You can see Stella's on the call. She's nodding her head. She actually she ran the study for us. She's the true master of the study here. But yeah, we did do that. Unfortunately, didn't publish everything on that, but we did try and look at some cognitive data. And we actually we did some work looking at some really innovative new cognitive methodologies for checking for non-blood-based biological age testing that we haven't published as well. So there's really some really interesting areas here that we'll hopefully be able to publish and follow on now that we kind of got this big work done.
Okay. Thank you so much, Brad. That brings us to 11. So yeah, thank you everyone for your time and attention. Thank you, Brad, for coming on and joining us. It's about your work. It's been totally fascinating.
I appreciate it. If anyone has follow-up questions, you can email me, brad@circulate.health or info@circulate.health. Happy to continue the conversation asynchronously. Just appreciate you all spending the time and your interest in what we're doing. And if you have questions, ideas, what you would like to see us do, let us know. So
Thank you so much.
take care, y'all. Have a great day.
All right, everyone. We'll see you next month.